Yeah. Good evening, children.
Good evening, ma'am.
Good evening, online students. Good evening, Florentina, Rajit, and Rajit and Rakshita.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Hi. Good evening.
Good evening, ma'am.
Good evening. Yeah. So we'll talk about the tests that we have taken up, online later, like maybe at past 8:30. Okay. So now let's start the next chapter, real numbers. All your questions regarding the test will be answered. Speak your mind. That's what it is. Do not grumble with your parents at home. They do not know. I'm not saying that they don't know maths, but they are completely ignorant about what is happening in the class. If you have a problem, you have to reach out to me. I will give you the solution. Okay, there's no point sharing it with your parents. So share it with me. You had some issues in taking up the online test. Some question was difficult to understand. Whatever, speak your mind. This is not school. This is not school. I am responsible. It is my duty to make all the children here comfortable. And, see, attending this class should serve the purpose. Why we here? I'm definitely not here to make things even more a burden for you, right? You want to lighten it. You want to, make this math journey as comfortable as possible. And together we are trying to achieve that. So just speak your mind. You don't have to rehearse in your mind as to, should I ask her like this or like this? Just talk. Just talk your mind. You have that liberty here. Just talk your mind. You felt that some was like not in, you have not taught us anything like that, but you asked us that question. Just talk it, let it be, let it just be as blunt as possible. You don't have to make it in a way that it pleases the teacher. Okay. So anything, so whatever it is, do not rehearse. Something comes to your heart and mind, let it come out of your mouth. Voice it out. All right. Feel comfortable. Feel free. There should be no tension at all for everybody, and particularly Tanishka now, because your mother was telling me that already you're taking it as a stress, the assignments and all that. No, classwork itself is more than sufficient. Whatever you do in the class here, no. Excuse me, Ritika, look at me. Okay, so whatever you do in the class, that itself is more than enough. Practice the same thing again. That is enough. Assignment, if you have that assignment, is for you to think and do it, because in the classroom, what happens in the classroom, I'm going on talking. Okay, so you don't have time to think and process the answer by yourself, because I give the question and I only tell you the answer. So I don't allow you to think basically in the class. So I'm explaining everything. So you just have to nod your head to acknowledge that you've understood. Okay, so why then assignment? Assignment is because you can think. So you have understood something from the class. Now you need to think, right? You need to assess if you have understood by doing the assignment. So when you do the assignment, you are able to evaluate yourself. Okay, this I've understood. So you feel nice by working the assignment. You feel nice that you're repeating also. One is repetition. The other thing is you are able to think and do it. You are able to recall what you've understood from the classroom and do it. So it gives you a good feeling. It gives you a good feeling. So assignment, if you're not able to complete, see, I'm not going to ask you. There is no punishment. There is no punishment. You're not going to be questioned in the class as to why you didn't submit the assignment. Last Saturday was the due date, right? Why did you not submit? It's not going to be like that here. See, something which is welcomed by some students are not by others. All of us see, I cannot judge everybody. See, this academics, one thing I cannot use to judge all of you. So if you're good in maths, then you're good. You're not able to do maths, then you're bad. No, it's not like that. There are so many other aspects of life, right? So do your best. If you think homework is a stress, talk to your parents about it. Take their permission, not my permission. I cannot grant you that. I cannot say, okay, don't do the homework. That your parents have to decide for you. So if your family feels that you are already into many classes and the child does not have time to do the homework, don't do. So that decision you need to take with your parents. That's not between you and me at all. My duty is to conduct the classes regularly, explain to make you understand, give you assignments to practice, because some of us want. Because some of us don't want to do the same sum from the classwork again. You feel that I've already done that in the class. How can I just work the same thing again? So you want something new. That is why assignment. So if you're comfortable with that, do it. Otherwise, I'm not saying, see, now don't go home and say that the teacher said don't do the assignment. No, 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 I'm not saying anything. Assignment I'll give. You have to work. But if you feel it's stressful, there's no time, you talk to your parents, you take their permission. You decide. I will not. If you come to me asking in the assignment, in the question answer தரலனா நான் சொல்லி தருவேன் அவ்வளவுதான். Assignment நீங்க பண்றதே இல்ல ரெகுலரானா நான் ஒண்ணும் பண்ண முடியாது. Because each one's lifestyle is different. So one student is into, another class for science, then dance, music, whatever. There is no time now. I can't force a child to do my maths assignment. Correct. So I am doing my responsibility. I'm giving you the homework. I conduct tests. So you don't take up the test now. I can't do anything. I am doing my duty. So you have to do yours. If it is too much for you, you talk to your parents, get their permission, and don't do certain things. Online tests, if you feel it's too much, so many tests I cannot write, there's no time. No, all of you don't stop doing it, okay? It's not for everybody like that. I'm like saying if it's really stressful, if it's really taxing, you can test, please do, okay? Otherwise, I can't make out how much you've understood. Assignments, yes. All right, take me correct. Don't misinterpret. Don't read between the lines. Is that fine? All of you? All right, Tanishka, relax. Okay, and you will be able to do more work. When you take look, எல்லாமே ஸ்ட்ரெஸ்ஃபுல்லா பார்த்தாக்க productivity கம்மியாயிடும். Relaxed ஆருங்க. Respect your body. If your body is tired, respect it. Don't do it. Take rest. Health is more important than anything else for all of us. All right? Yeah, you can do it. Take care. Yeah, so 8:30, please remind me to stop and discuss statistics, children. Otherwise, I'll keep going with real numbers. I'll not remember. 8:30, just remind me. Or 8:30 to 8:40, remind me. Okay, so we're going to see this chapter real numbers in some 3 to 4 parts, So now the first part, what we're going to see in today's class is about finding the LCM and HCF of 2 or 3 numbers using the prime factorization method and the division method. We are dividing this chapter real numbers into 3 to 4 parts. The first part, what we're going to do today is to understand how to find the LCM and HCF of 2 or 3 numbers max. That's all we have. Okay. So LCM, HCF of 2 to 3 numbers by the prime factorization method and the division method. And we'll also see the applications. We'll also see the applications of LCM and HCF, where we use it, where is it applicable. So we'll also see that through some questions. So that is for today's class. So you should have got a different, do you have a new book? Or that book itself? Okay, make some demarcation, like take a page and write real numbers. No, just write one page, this page, the next page, write real numbers. Yeah, don't fold, then you can't write. Just write giant letters, write real numbers. Yeah, then start from the next page. Don't fold, then you can't write, no? Yeah. If you have a new book, use a new book. See, again, all that is your choice, children. I'm just suggesting. There is no force. I'll ask you questions. What are real numbers? We'll come to all that later. The term real number is not new to you. Correct? It's not new to you. So I'll come to all that later. We'll just get started with this. Yeah, you can start writing this.
Ma'am, your screen is not shared.
Sorry, I didn't realize that. It's visible, right, children?
Yes, ma'am.
Yeah, ma'am.
Yeah, thanks, Madhumita. Okay, so here X, Y, and Z are some three composite numbers. So we know that every composite number can be expressed as a product of primes. Every composite number can be expressed as a product of primes. Now 10 is a composite number. Why? Because it can be written as 2 into 5. 10 is a composite number because it can be expressed as 2 into 5, where 2 is a prime number, 5 is also a prime number. 15 is a composite number because it can be expressed as a product of primes. 15 is, see, now you will say 20 is 5 fours are. You will say 20 is 5 into 4. Where is 4 a prime number? It can be expressed, no, so 20 is equal to 5 into 2 into 2. Now don't say 20 is 10 into 2. 10 is not a prime number. No, 20 is 5 into 2 into 2. Correct? Okay, so every composite number can be expressed as a product of primes. This is the fundamental theory of arithmetic. I'll write all this for you. This is the fundamental theory of arithmetic. Every composite number can be expressed as a product of primes. For example, 50. 50 is what? 25 into 2. But 25 is further 5 into 5. So 50 is 2 into 5 into 5. So the 50 is a composite number because it can be expressed as a product of prime numbers. Correct? Okay. So here X, Y, and Z. Look at the board. X, Y, and Z are some three composite numbers. X, Y, and Z are some three composite numbers whose prime factorization is given there for you. So X is some number which can be expressed as 2 cubed into 5 squared into 7. All right. Y is again a composite number which can, now why did I say Y is a composite number? Because it can be expressed as a product of primes. You can see Y is 2 into 2 into 3 into 5 into 5 into 5 into 5. You're able to express Y as a product of primes. So Y is a composite number. Z is also a composite number. Why? Because you can see the prime factorization there. 2 into 2 into 2 into 2 into 3 into 3 into 3 into 5 into 5 into 5. So X, Y, and Z are composite numbers because we are able to express them as a product of prime numbers. Now we're trying to find the HCF. of these three composite numbers using the prime factorization method. Now, you'll have to first write out, you'll have to first list all the common primes you see. The three numbers are X, Y, and Z. What are the common primes? Is 2 a common prime factor? Yes. Is 3 a common prime factor? No, because 3 is in Y and Z, but not in X. So 3 is not a common prime factor. Is 5 a common prime factor? Yeah, right, 5. I've not written the powers. Then is 7 a common prime factor? No. Write only the common primes first. That is the first step. Now, what are the prime numbers you see here? 2, 3, 5, and 7. The different prime numbers we see here are 2, 3, 5, and 7. But the common primes are only 2 and 5. So first we'll have to write this. Okay. Now raise these primes to the least power. Least power. So 2 cubed, 2 square, 2 to the power 4. Least power, 2 square. 5 square, 5 to the power 4, 5 cubed. Least power, 5 square. This product is the HCF of X, Y, and Z. So that is what is the definition. HCF is the product of the least powers of the common prime factors involved. Common prime factors, least power. HCF is, so that rule you'll have to remember. HCF is common prime factors, smallest power, least power. LCM will be all the prime factors, highest power. Write all the prime factors, whether it is common or not common, whatever different prime numbers you see, write everything and raise everything to the highest power. That product will give you the LCM. Just the opposite of HCF. Yeah. For LCM, write all the primes you see. So if you have to find the LCM of X, Y, and Z, write everything 2, 3, 5, 7, write all. No common, not common. Everything. What all do you see? 2, 3, 5, 7. Write everything and raise everything to the highest power. 2 to the power 4, 5 to the power 4, then 3 to the power 3 and 7. Okay, in the order I'll say again. 2 to the power 4 into 3 to the power 3 into 5 to the power 4 into 7. Right? All the primes highest power. That's the LCM. Common primes least power is the HCF. That's all. Okay, so this product, so this is 4 into 25. 100 is the HCF of these three composite numbers X, Y, and Z. That's all. If you understand this, that's all. This is only HCF and LCM using the fundamental theory of arithmetic or the prime factorization method. Right on. This is the main heading. Done, children? Yeah.
Yes, ma'am.
Yeah. So now we'll find the LCM of the same numbers. Okay. Can you just close the door? The main. Yeah, children, now what did I write? Tell me X is equal to what?
2 cube.
Into? Next. Next. 2 squared, huh? 2 square into Into 3 power 3 into 5 power. 5 power? Okay.
2 to the
Now?
power 1.
Sorry?
2 to the power of 2, ma'am, Z1.
2 squared, huh? No, 2 to the power 4.
Sorry, ma'am.
2 to the power 4. Okay, write this first. I forgot to write. So what is LCM? LCM is the product of the highest, no, product of the highest power of all the prime factors involved. Prime factors involved. LCM is the product of the highest powers of all the prime factors involved. So what will be the LCM of X, Y, Z? Right? All the primes. You see 2, you see 3, you see 5, you see 7, and the highest power 4, 3, 4, and that's it. Maybe that will calculate it. So the huge number, you can just copy this. So just 189 followed by 2 4 zeros. 1, 2, 3, 4 zeros. All right. So now having done this, we'll define the fundamental theory of arithmetic. It's called FTA, fundamental. In some books, it is theorem also, whatever, of arithmetic. It's called FTA, or the prime factorization method. FTA represents the prime factorization method. Okay, so FTA, the fundamental theory of arithmetic, states that every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. Because if you ask me 20, I will say 2 into 5 into 2. But she's more disciplined. She'll say 2 into 2 into 5. She'll say you should say in order. You can't say 2 into 5. So Danya will say in order because she's very disciplined. She'll say 20 is 2 into 2 into 5. I'll say like 2 into 5 into 2. Somebody else will say 5 into 2 into 2. So, but all of us are saying the same numbers, right? 2, 2, and 5 only. That's what it is. Every composite number, so 20 is a composite number. It can be expressed as a product of primes. That is 2, 2, and 5, 2 into 2 into 5. And this factorization is unique because all of us are getting the same thing. All of us are getting the same primes. All of us are saying 2 to 5 only, but the order is different. And this factorization is unique. Unique means there's only one answer. Unique means only one answer is there. Correct. So this factorization is unique apart from the meaning, except for the order in which the prime factors occur. The order can be different. So like I'll say 33 is 3 into 11. He'll say 11 into 3. But both of us are getting 3 and 11 only as primes. That is what is the definition of FTA, or the fundamental theory of arithmetic. It states that every composite number can be expressed as a product of primes. Isn't that easy to remember? Every composite number can be expressed as a product of primes. And this factorization is unique because all of us will get the same answer. But what can be the difference apart from the order in which the prime factors occur? This is the definition. Remember, as it is, sometimes you'll be asked to state the theorem. All right. So states that, write down, states that every composite number can be expressed as a product of primes, as a product of prime numbers. Primes meaning prime numbers, as a product of primes. And this factorization is unique. All of us will get the same answers. Unique apart from the order in which the prime factors occur. Done, children? All of you?
Yes, ma'am.
Very good.
Yes, ma'am.
Yeah. All right. Now this is a question for you. Find the HCF and LCM of 184, 230, 276 using FTA. Using FTA meaning the prime factorization method. Prime factorization method. Yes. No, you should not do this method, children. See, I think some of us are doing this 184, comma. No, this is, should not do like this. You must write the factors separately. Like this. You must express each number, each composite number as a product of primes. This is the middle school method. Don't do that now. You have learned like that in school? Okay, it's not like that. No. Fine. If your teacher is fine with that, fine. You need to express, we have three composite numbers. We need to express each of them as a product of primes. And then find the LCM and HCF using that definition. Your school has taught this method, you can do it, children. Yes. How do you express 184 as a product of primes?
Ma'am, can I say?
Yeah, yes, Prajit.
I'm 2 square into 3 into 17.
I'm scared you're wrong. Very good. 2 cubed into 23. Prajit, please check your working. It's 184. Have you written 189 or something else? Please check that.
No, ma'am.
It's 2 cubed into 23. 230. 2 into 5 into 23. 276.
2 cube into 3 into 23, ma'am.
2 cubed.
Sorry, 2 square, ma'am.
2 square into?
3 into 23.
Correct. So if some of us are wondering like how can we write this? It's like this. It's like this. You'll have to take up each number 184. Start with the smallest prime 2. 2 nines are 18 2 times. 2 46 times. Again 2 23 times. And 2 is a prime. 23 is a prime number. So 184 is 2 cubed into 23. Then take the next number 230. 2 115 times. Then 3 threes are 9. Oh no, 3 it's not divisible. Sorry, 5. 5. So 5 twos are 10. So 2 into 5 into 23, and like that for 276 also, like this. So Florentina. HCF of 184, 230, 276 is equal to. Should we write all the primes or only the common primes, Florentina?
Ma'am,
Common primes, all primes.
only the common primes.
Yeah. So which are the common primes?
And 2 and 23.
Least power or highest power?
Least power, ma'am.
So tell me.
46.
Very good. Tanishka, do you want to try LCM? Common primes or all primes, Tanishka? All primes. So what are the different primes you see there? You see, forget the power. Don't say the power now. The different primes you see. So 2, you see 2, then you see 3, then 5, and then 23. These are the different primes involved. Now raise them to the least or highest power. Highest power. Tell me. 2 cubed, then 3. Yeah. Yeah. Very good. So this product is the LCM. It's as simple as that. 8 into 15 into 23. 2760. Correct. 2760. Everything that's on the board should be in your book. Randomly, I'll see somebody's book. If something is missing in the class, everything should be perfect. Otherwise, yes, you will be taken to task. Everything should be written in your book. No drawing. If you're free, don't draw something and start coloring it. Don't do all that. Start drawing something and shading it. This is over, children. Yeah, now we learned how to find. Yeah. So we are done with the fundamental theorem of arithmetic or theory of arithmetic. We know how to express every composite number as a product of primes. If you know FTA, that means you know how to express every composite number as a product of primes. So we know that. And using this concept, that is the prime factorization method. Okay, using this concept, we have learned how to find the LCM and HCF of three numbers. What have we learned now? We understood what FTA means. And using the concept, what is FTA? Simply writing every composite number as a product of primes as FTA. And using this, we have learned how to find the LCM and HCF of 2 or 3 numbers. Now let's learn how to find the HCF using the division method. Only HCF. We learn how to find HCF using the division method. Now for the same three numbers, we'll find the HCF using division method. All right. So to find the HCF using the division method, take any two numbers at a time. Any two numbers at a time. Okay, so we normally take in the order. We arrange the numbers in the ascending order. So it's already in the ascending order, 184, 230, and 276. Take the first two numbers. Take the first two numbers. So you basically start like this. You can do this method is okay. Just follow me. So do this in the rough column. Okay. So it's like this. Do this first, and then write the greater number inside and the smaller number. That is the greater number. 230 is the dividend and 184 is the divisor. All right. Okay. Take the first two numbers. The bigger one is the dividend. The smaller one is the divisor. Now divide 184 once is 184. What's the remainder? 6. Then I think is it 4? Please help me. 5. Yeah? Is the subtraction correct? Yeah, it is correct. Yeah. Okay, now see here. See what I've done. Write this one. The earlier divisor becomes the new dividend. The earlier divisor becomes the new dividend. See, in every stage to divide, you need two numbers. In every stage to divide, you need two numbers. One number is the dividend, the other number is the divisor. To divide, you need two numbers. With one number, you cannot divide. You need two numbers to divide. Of the two numbers, one number is called the dividend and the other number is called the divisor. So every stage to divide, you need two numbers. Dividend, divisor, dividend, divisor. So now first, who was the dividend? The bigger number was the dividend and the smaller number was the divisor. Now you perform the division. 184, subtract, you got 46. Now you want to divide again. You want two numbers. You want one dividend and divisor. The remainder is the divisor. You want to dividend now. The earlier divisor becomes the dividend. Okay, the earlier divisor becomes the dividend. 184 comes here. After performing the division, you want two numbers again. Dividend, divisor you want. divisor is the remainder only, 46. You want the dividend, you want a dividend. The earlier divisor becomes a dividend. This 184, put it here. Now again divide. 46, how many times 184? It may be exactly divisible, it may not be exactly divisible. Four times 184. See here in this division, you know, you can go even beyond 10. You can write like 46 11s are also. See, in the regular division, you don't go beyond 9, right? In the regular division, we don't go beyond 9, right? Here you can even write 46 13 times something. Whatever dividend you have, you should find a number close to that. Exactly that or just less than that. So that can go even beyond 10. You can find 46 10s are, 46 11s are, 46 12s are, 13s are. You can go beyond 10. Remember that. Don't stop at 9. You have to find a number which is exactly the dividend or a number just less than the dividend. Yes or no? That's what we always do. What the product you get should be the dividend or a number just less than the dividend. For that, you can go even beyond 9, 10, 11s or 12s or 13, 14, 25, 30, whatever number. Okay. So in one shot, you should divide. In one shot, you should finish the division. So here 46 4s are, it is 184, the remainder is 0. That means the HCF of these two numbers, 184 and 230. 184 and 230 is 46. Why 46? The last non-zero remainder is called the HCF. You will understand. I'll repeat everything. Don't worry. So now tell me the remainders in different stages we got here. The final remainder is 0. The earlier remainder was 46. Which are, see, first number divide panappa, what was the remainder? 46. Then we perform the division. What was the remainder? 0. So what are the different remainders you got? You got 46 and 0. And the 0 varathukku munnadi, what was the remainder? 46. That only is the HCF. The last non-zero remainder. The last non-zero remainder is the HCF of the two numbers. Now, supposing you had some 10 steps, then finally you get 0. You should go on till you get 0. You should continue the division till you get 0. And so some 10 steps you got 0 as a remainder finally. Okay, so which is the HCF? You see the remainders. Before 0, before remainder 0, that earlier remainder, that is the HCF of the two numbers. So when you do this method, the division method, the HCF is the last non-zero remainder. Zero remainder, non-zero remainder. Remainder, so 46 is the HCF. All right. Now we shouldn't stop there. We have to take the next number 276. So now continue the division. So it will be like take the next number 276 because and take the HCF 46. Take the HCF 46 now. Take the HCF 46 and the third number 276. Okay, now do. Perform the division. Try to get 276 or a number just less than 276. 6 times. 6 6 are 36, 3 carried over, 6 4 are 24. Exactly. Exactly. You can go even beyond 10 level, I'm telling you. So this only is the the HCF of all the three numbers. Now, how do you present it? How do you present it? So start from 230. Start from 230. The dividend 230. The dividend 230 can be expressed as 184 into 1 plus 46. Correct? Plus 46. So there's a formality. You have to write this. We got the answer. We got 46. But you'll have to write this. Okay. So 230, the dividend 230 is equal to 184 into 1 plus, see this 184 into 1 is one thing, plus 46, the remainder. Correct? Now the next dividend, what is that? 184 is plus 0. Just circle this and say the HCF of 184 and 230 is 46. Next, here what did you do? 276 is equal to 46 into 6 plus 0. So HCF of 184, 230 and 276 is 46. Is 46. This is the division method. In both the divisions, you will have to go on till you get remainder 0. Till you get remainder 0. You will get 0. You will get 0. Yeah, right on? No. Normal regular division will not help. Is that fine, children? Finished? Done, children?
Yes, ma'am.
Yeah. Arjun, you joined us late, right?
No, ma'am, I joined before itself.
Okay. But why online, Arjun?
Ma'am, today I was unable to attend in offline. Ma'am.
So you'll have to text me, okay? Keep me informed. If you're attending the classes online, keep me informed.
Okay, ma'am.
Yeah. You write the correct question number, okay? So I'll just write 3. Sometimes I'll miss or whatever. You write the correct question number, okay? So what is the largest number that divides 765, 510 and 408 exactly? So listen to this very carefully. Don't start working now. Listen to this very carefully. Now, whenever we divide, we have something called the numerator and the denominator. Okay, or we say dividend and divisor. Dividend divisor, or we have the numerator, like when we write 10 by 2, 10 by 2. We have the numerator and denominator. Otherwise, we have the dividend and divisors. But anyways, we have two numbers. Now, in this chapter, you will have some situations where you have to find the LCM. Some other situations when you have to find the HCF. Now, you can easily identify that from the question. If you're looking for the numerator, then you have to find the LCM. If you're looking for the denominator, you have to find the HCF. Remember that. Remember all this. I'll repeat. So like this, I'll write like this. If you're trying to find this, if you're trying to find the numerator, you'll have to find the LCM. If you're trying to find the denominator, you'll have to find the HCF. Remember this. Another thing. Now, how do these two numbers behave? LCM is always the greatest. Supposing we'll take only three numbers, okay? Because we normally have only three numbers max. So LCM is the greatest of the three numbers, or a number greater than all the three numbers. Now you can check that. Now, for example, the LCM of 10, 50, and say 100. Okay, the LCM of 10, 50, and 100 is 100 itself. The greatest of the three numbers. Okay, but if it is 10, 50, and say 80 and 80, then the LCM is 400. It's greater than all the three numbers. So how does LCM behave, or how does it look like with respect to the three numbers? So LCM can be the greatest of the three numbers, or a number greater than all the three, greater than the greatest number. Take this example, 10, 50, 100. What's the LCM? The greatest number, the biggest number, 100. Take the other example, 10, 50, 80. What's the LCM? It's not 80. It's something more than 80. 400 it is. So it can be one of the three numbers. That is the greatest of the three numbers, or some number greater than the greatest number. You understand this, no? Okay. So in the case of 10, 50, and 100, one of the numbers, that is the greatest number, 100 itself is the LCM. But in the other example, 10, 50, 80, 80 is the greatest number, but that's not the LCM. The LCM is 400. So it's bigger than 80. So that means, so in this case, LCM cannot be less than 80. In this case, LCM cannot be less than 100. Either it is 100 or more than that. In this case, LCM is either 80 or more than 80. So in that situation, if you're looking for a number bigger than the three numbers, that means you have to find the LCM. In that particular, so it's a situation. It is a situation now. It's a word problem. It's a situation. Now we'll have to decide if I have to find the LCM or HCF. So just take those three numbers and ask yourself, should the answer be more than the three numbers? Then it is LCM. If the answer should be something smaller than the three numbers, it should be the HCF. Now, what is the HCF of 10, 50, and 100? 10. What's the HCF of 10, 50, and 100? 10 is the HCF. What's the HCF of 10, 50, and 80? 10 itself. Now, what is the HCF of, say, 3, 6, and no, 1 minute. Let me say 4, 6, and 10. 4, 6, and 10. What's the HCF of 4, 6, and 10? No. 2. So, HCF of 4, 6, and 10 is 2, is smaller than the smallest number 4. Now, in the case of 10, 50, and 80, in the case of 10, 50, and 80, what was the HCF? 10, the smallest number. LCM is the smallest number, 10. In the case of 10, 50, and 100, HCF is 10. HCF. In the case of 10, 50, and 100, HCF is 10. In the case of 10, 50, 80, HCF is 10. In the case of 4, 6, and 10, not 4, smaller than that, 2. So that's how HCF is with respect to three numbers or three or more numbers. So HCF is the smallest of the three numbers, or a number smaller than all the three of them. HCF can be the smallest of the three numbers. If it is not the smallest of the three numbers, then it is a number smaller than that smallest number. So LCM means it is the biggest number or something more than that. HCF is the smallest number or something smaller than that. This is how HCF and LCM, look like with respect to three numbers. So in that particular situation, judge the value you're expecting. If you're expecting something more than the given numbers, then you have to find the LCM. If you're expecting a number smaller than the given numbers, then it is HCF. Okay, and then this is one thing. And the other thing is the word divides and divided. So let me write all that. You can just make a note of all this. LCM of three numbers may be the greatest number or a number greater than all the three numbers. So these things, you should always know. Meaning, when you're eating, you should try to recall all this. Just when you're just eating, just think of all this, just do that rehearsal in your mind. You must be thinking of this kind of regularly till you can remember forever. இதெல்லாம் வந்து எக்ஸாம்க்கு முன்னாடிலாம் பார்த்துட்டு இருக்க கூடாது. That means that is not going to work. Little things like this, should always remember. You must keep telling this, and you make sure that you always remember this. In the chapter, revise பண்ணதுக்கு ஒண்ணுமே இல்ல exam. It's full of numbers and some ideas. Some half an hour you should be able to revise the whole chapter. So you understand the first one, no? LCM of the three numbers, maybe the greatest number, that you understand. HCF of three numbers, that also you understand. If you're looking for the numerator, you have to find the LCM. If you're looking for the denominator, NR is numerator, DR is denominator. If you're looking for the denominator, that means you should find the HCF. If you find the word divides in the question, divides, that means HCF. Divided, LCM. All right. Okay, now look at this question. What are the largest number that divides? Divides, that means what? Refer. Divides mean HCF. Should find the HCF. What are the largest number that divides? These three numbers exactly correct? No, now just ask yourself a different question. Now, supposing you have numbers 30, 40 and 75. Okay. Now ask yourself, which is the biggest, I'll take a different example. 1 minute. Don't start working, children. Listen to me. Now you're looking for a number that divides these three numbers exactly. You're looking for a number. Idhe question da. When the numbers are large, we don't understand. But you take the same question, you take smaller numbers, you will be able to understand. Now read the question. What is the largest number that divides 10, 15 and 25 exactly? What's the largest number that divides 10, 15 and 25 exactly? What's the answer?
5, ma'am.
5. 5 is the number that divides 10, 15 and 25 exactly. And what is 5 for 10, 15 and 25? Is it the LCM or HCF? It's the HCF. That's all. That's what we're doing. That's what we're doing. So you should find the HCF of these three numbers. So you're finding the biggest number that divides these numbers exactly. Now look at this. 20, 40 and say 60. Are all these three numbers divisible by 2? Yeah. Are all the numbers divisible by 4? Yeah. Are all the numbers divisible by 4? Yes.
Yes, ma'am.
Yeah. Are all the numbers divisible by 5? Yes.
Yes, ma'am.
Yeah. Are all the numbers divisible by 10?
Yes.
Yes.
Yes,
Are
ma'am.
all the numbers divisible by 20?
Yes.
Now, yeah, that is why the word largest number. That's why largest number. What is the largest number? Because 2 also divides these three numbers exactly. 4 also divides these three numbers exactly. 5 divides these three numbers exactly. 10 divides these three numbers exactly. 20 also divides these three numbers exactly. And what is 20? It's the largest number. That's why the question is, what is the largest number that divides these three numbers exactly? Because if you simply ask what is the number that divides these three numbers exactly, he will write 2. Yeah, 2 divides everything exactly. She'll write 4. Yeah, correct. No, 4 divides everything exactly. You will write 5. Correct. You will write 10. So that means the question does not have a unique answer. The question does not have one answer. So that word largest. What is the largest number? The biggest number that divides all the three numbers exactly. And that is the HCF 20. Because there are many numbers that divide these three numbers exactly. 2 divides all these three numbers exactly. 2. 4 divides all these numbers exactly. 4. Correct? 5 divides all these numbers exactly. 5 also divides all these numbers exactly. 10 divides all these numbers exactly. But 20 is the greatest number that divides all these three numbers exactly. That's why the question, what is the largest number that divides these three numbers exactly? Divides means HCF. This largest and divides together means HCF actually. Actually divides not denominator, dane. It divides meaning it will come in the denominator. So now you think about it. Divides means denominator. And denominator is the largest number. That's why largest and divides, these two come together to represent HCF. Understood? Yeah, now do this by FTA. Find the HCF of these three numbers by. So instead of asking you to find the HCF, the question is what is the largest number that divides these three numbers exactly? That means you should find the HCF. Yes, find HCF using FTA. Using FTA and EDA. We'll do it both the ways. First find using FTA. 765 is equal to 510 is equal to 408 is equal to. So for that you should find separately 765, separately 510, separately 408.
Ma'am,
Yeah.
I think the answer is 51.
The final answer is 51, is it?
Yes, ma'am.
No, that means you okay. Tell me the prime factors of 765, Florentina.
5 into 3 power 2 into 17.
Tell me the order. 3 power.
2.
Okay, into
5 into 17.
17. Okay, next 510.
5 into
Ah,
2 into
ah.
3 into 17.
1 minute. We should always write in the order, okay? 3 into 7, 3 into 5 into 17. Okay. Okay, Florentina, good. You also got the correct answer. 1 minute. We'll just wait for the others to finish. Yeah. I'll get the third one from. Yeah, good, Florentina. Yeah, what is 408? 2 cube into 3 into 17. All of you get this? Okay, good.
Yes, ma'am.
Very good. Now, Arjun, tell us, how do you find the HCF? HCF of 765, 510, and 408. Quick. All factors or only common factors? Rakshita,
Ma'am, only common factors.
common factors. So which are the common factors?
3 and 17.
3 and 17. Least power, greatest power.
Least power.
Okay, very good. So the HCF is 51. So you must write 51 is the largest number. 51 is the largest number that divides 765, 510, and 408 exactly. Now, for the same three numbers, find the HCF using the division method. Take two numbers at a time. You can take any two numbers. But the greater number should be the dividend. The smaller one should be the divisor. Any two numbers, which one have you taken? 765 and 510. So 510, one's a 510. 255 is a remainder. Okay, then 2 times 510. 0. So the HCF of 765 and 510 is how much? 255. Now you must take 255 and the third number 408. The greater number is the dividend. So put that inside. The greater one is the dividend. So put that inside. Meaning that's the dividend, right? So how many times now? Once 255. Yeah, then 153. Okay. Yeah. You're working. Okay. But no, I think I need more place. So I'll just write it again. I'll do this again. You have a doubt? No, no. You can ask from there. Yeah, we'll do it. We'll do it. You have changed the order. We'll do it.
Ma'am, after dividing 153, I divided 153 by 51 by mistake, ma'am.
Mm.
And I still got the same answer, 51.
It's a mistake. No, you've done a mistake. So correct it. That's all.
Ma'am, but I still got the same answer.
No, but you know you've done a mistake, right? So why, what justification can I say for that? If you have not made any mistake, but have a different step and got the same answer, we have to talk about it. You know you've gone wrong somewhere. Have you gone wrong or what are you trying to say?
Yes, ma'am.
Yeah, then you'll have to correct it. That's it.
Yes, ma'am.
Can I clear the slide, children? Online students?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Yes, Ritika? No, but you want to clarify something or you're fine? No, you tell me. We'll start with what are the two numbers you took up? 408 and 510 first. Okay, so 408 and 510. Okay, and 510. So once 408, 102, 408, 4 times 408, 0. Okay, so that means the HCF of 408 and 510 is 102, correct? Now you need to work with 102 and the third number. 102 and the third number 765. 765. So how many times? 7 times is 714. Okay, remainder 51. Yeah. 2 times 102. And 51 is a HCF. Okay, so 51 is the largest number that divides these three numbers exactly. So got that? Okay, next. How many of you learned real numbers in school already? You've learned. You? No. You? You've learned. No. Okay. You just finished 9th standard. Yes, here, Madhumita,
Yes, ma'am.
Arjun,
Not yet completed.
Rajit. Rajit, you have not, you're still in 9th standard, right? Okay, Rakshita and Florentina.
No, ma'am.
Okay. Florentina, you must have learned, no? The other day your mother texted me that you have finished real numbers in school.
Yes, ma'am. I said yes, but we both spoke at the same time, so you heard it as no.
Sorry?
Ma'am, I said yes, it is completed at school.
Oh,
Ma'am, did you call me?
yeah. No, Prajit, have you finished your 9th exams?
No, ma'am, it's on 13th, starts on 13th.
13th, okay, fine. Yeah, so this question is express the HCF of these two numbers as a linear combination of the two given numbers. All right, so again, we need to use the division. Tell me, no, we'll do it together. Tell me, help me. How many times? Okay, work this and tell me, I'll just take it from you. So finish it completely and tell me, yeah. Done? Yes, done you? 2 times? 1? Yeah. 1? Okay. Five? So what is the HCF of the two numbers? HCF of 575 and 1288 is 23. Now we have to express 23. Express the HCF of these two numbers. That means you'll have to express 23. See that, express the HCF of the two numbers. That is, we need to express 23 as a linear combination of the two given numbers. The two given numbers are 575 and 1288. So we'll see how to do that now. So since it's express the HCF, you should start with the HCF. Express the HCF. So start with the HCF. So start with 23 is equal to HCF is equal to. Don't write. Listen to me. 23 is equal to. Simply use the division algorithm. Division algorithm. We all know dividend is equal. Dividend is equal to divised into quotient plus the remainder. We all know that. Dividend is equal to divised into quotient plus the remainder. Use this division algorithm and express 23. 23 is equal to 23 is what? It's a remainder, right? So how do you express the remainder? It is the dividend 575 into 4. Use the division algorithm. Remainder is equal to what? Okay, I'll not write 575. You tell me what to write. Uh, 23 is equal to 138 into 4. 138 into 4 plus how 23 is equal to, and again you'll write 23 there. Remainder is division algorithm 23 is equal to 23 எழுதலாம்.
Ma'am, 138 into 4 minus 552. No.
One second, Madhavita. Yes, Danya, louder and again. 138 into 4 minus 575. Is that what you're saying? Yes, Madhavita.
138 into 4 minus 552.
Minus 552. Yeah. Okay. 138 into 6. No. Okay. Three fours are 12, right? One is a remainder. So how do you write? 13, the dividend 13 is equal to 3 into 4 divided into quotient plus the remainder. So what will be the remainder 1? 13 minus 3 into 4, right? எனக்கு தெரியாது நீங்க தான் சொல்லணும். இப்ப நான் இங்க எழுதிட்டது கரெக்ட்டா இல்லையா? I'm dividing 13 by 3. The regular division 13 by 3. 3 fours are 12. 1 remains. How do we apply the division algorithm? The dividend 13 is equal to divised into quotient. Divised into quotient is one thing plus the remainder. So remainder is equal. Remainder 1 is equal to this remainder 1. The remainder 1 is equal to transpose pannunga 13 minus 3 into 4. Yes or no? Transpose panna 1 is equal to 13 minus 3 into 4. So dividend minus divised into quotient. No, that's what you should say. Remainder is equal to dividend 575 minus 138 into 4. Yes or no? Now next 23 is equal to 575 minus. Now here, which is the remainder? Keep replacing the remainder. Now here 138 and 4 lay the remainder. Okay, what are the different remainders? 23 kapra, what is the remainder? 138, right? After Ritika, you'll have to listen. So what are the remainders here? 23 and 138, correct? Forget the zero remainder. What are the different remainders here? 138, 23, 0. Forget 0. So what are the other remainders? 138 and 23. We started with 23. So there is only one more remainder, which is 138. Do the same thing for 138. So instead of 138, so put that 4 outside. Put that 4 outside. What is 138? 138 is 1288 minus 575 into 2. Yes or no? No, I'll write again. எனக்கும் இடம் இல்ல. உங்களுக்கும் திருப்பி சொன்ன மாதிரி இருக்கும். Let me write it again. Here, I start with the HCF. Because we have to express the HCF. So you have to start with the HCF. And simply use the division algorithm. The remainder 23 is equal to the dividend 575 minus the divisor 138 into the quotient 4. Now write the same thing. Write this 235 to 23 as it is. Because 575 as it is, because that is not the remainder. Only the remainder you should not write as it is. Remainder should be replaced with dividend minus divisor into quotient. The others will come down as they are. 575, is it the remainder? No, write it as it is, minus. Here 138 and 4, which is the remainder? 138 is a remainder. That should be replaced. Upon the into 4, அப்படியே தான் இருக்கும். So on the into 4 இங்க போட்டுறேன். ஏன்னா 138 க்கு ஒரு பெரிய expression வரும் தெரியும் நமக்கு. So we are providing that space for 138 into 4. Sorry, 138. And that 4 I'm putting it outside. Is it fine, children? Into 4. Now what is 138? 138 is the dividend, this one, minus and the into 4 வெளியில போட்டுருக்கோம். அவ்வளவுதான். இப்ப இதுக்கப்புறம் திருப்பி சப்ஸ்டிடியூஷன் இருக்காது. ஏன்னா ரிமைண்டர்ஸ் எல்லாத்தையுமே மாத்திட்டோம். ரிமைண்டர்ஸ் மட்டும் தான் மாத்தணும். And we have changed all the remainders available. That's all. Now we should just simplify this. Okay, so 23 is equal to 575 minus multiply by 4. So 1288 into 4 minus into minus plus. இப்ப என்ன क्वेश्चन இந்த 4 2 க்கு மல்டிப்ளை பண்ணணுமா இல்ல 4 575 க்கு மல்டிப்ளை பண்ணணுமா? கோஷன்ட் க்கு மல்டிப்ளை பண்ணுங்க. கோஷன்ட் எது? 2 தானே கோஷன்ட். அதுக்கு தான் மல்டிப்ளை பண்ணனும். So 575 into 8. 2 4s are 8. I'm multiplying this 4 outside, no? So 1288 into 4. Then minus into minus, minus into minus plus. Now here we have 575 into 2. Into 4 you should do. Now should we multiply 575 with 4 or 2 and 4? ஏதாவது ஒன்னு தான் பண்ணணும். So அதுல எது quotient? 2 is the quotient. அதுக்கு தான் multiply பண்ணணும். So 2 into 4 8. Now 23 is equal to, there is 575 means 575 into 1. வெறும் 575 இருக்குன்னா 575 into 1. Okay, if it is 575, it is 575 into 1. Okay, so here there is 575 into 1. Here there is 575 into 8. So you'll get 575 into 9. It's like A plus 8A. A plus 8A is 9A. A plus 8A is 9A. இங்க A என்ன 575. அங்க 8A. 1 into 575. Okay, if you want the steps, these are the steps. See, I'll show you. See, we have 575 here. 575 into 1 and 575 into 8. So what is common? 575 தானே common. இப்ப bracketல என்ன வரும்? 1 plus 8 தானே வரும். அப்ப 9 தானே அது. That's what it is. 575 into 9. So it's like 1A plus 8A. 8A. 1A plus 8A is 9A. All right. So 575 into 1. ஒரு 575 இருக்கு. அப்புறம் இங்க எவ்வளவு இருக்கு? 8 575 இருக்கு. அப்ப மொத்தம் எவ்வளவு 575 இருக்கு? 9 575 இருக்கு. அதான் 575 into 9. 575 into 8 means there are 8 575s. 1 into 575 இன்னும் ஒன்னு இருக்கு. அப்ப மொத்தமா 9 இருக்குன்னா 575 into 9 minus 1288 into 4. Now we should always, if nothing is mentioned, you should take a plus sign in the middle. If nothing is mentioned, it's a plus sign in the middle. So it becomes 1288 into minus 4. So now see, this is the last step. So see, we have expressed the HCF 23. Okay, well, let me write one more. Is equal to 575A plus 128B, where A is equal to 9 and B is equal to -4. Now see the last step. Have we written 23, the HCF, as a linear combination 575A plus 1288B? A linear, no, linear. A and B meaning linear, X and Y. Linear. Linear combination of the given numbers 575 and 1288. You can see the final step has the two numbers 575 and 1288. And you can see A and B, a linear combination of the two given numbers. We have expressed the HCF 23 as a linear combination of the two given numbers 575 and 1288. How is it a linear combination? Because A is not raised to the power 2. Then it becomes a quadratic one. A is raised to the power 1, B is also raised to the power 1. So linear. If nothing is mentioned, you should take a plus sign here. So that 4 will become -4. Is this okay? Write down, children. Write down carefully. Next is a test. FA 3. First question. In the second step, 575. The second step, in the multiplication 1. 575 into 2 into 4. No, you're disturbed. You know that the two given numbers are 1288 and 575. You should not disturb 1288. You should not disturb 575. You should not disturb them. You must not disturb 575 and 1288. So if you multiply at whatever, 575 is gone.
Ma'am, how do we get 575 into 9 in the fourth step?
Madhumita, is it?
Yes, ma'am.
Okay. So do we have 575 into 1, Madhumita?
Yes, ma'am.
And do we have 575 into 8?
Yes, ma'am.
What is common between 575 into 1 and 575 into 8?
575.
So what do you get in the bracket? 1 plus
8.
What is 1 plus 8?
9.
Yeah. Okay.
Yes, ma'am.
Yeah.
And can you tell me how did you get -4?
Yes, yes, sure. Yeah. So if nothing is mentioned, you have to, the connector should be a plus sign. Okay. Is it okay till here, this step, Prajit?
Yes, ma'am.
Okay. So in the next step, the connector should always be a plus sign. It's just a formality. Okay. The connector should be a plus sign. So now it's minus. So we take a plus and that minus is taken with 4 here. So 4 becomes -4. See here, minus into plus, minus into plus minus. This is one expression. 575 into 9 is one expression. 1288 into 4 is another expression. This minus, we are fixing it with 4, -4. So we change this minus to plus.
Yes, ma'am.
No. Am I clear or shall I tell you again?
Now I'm clear.
Okay. Yes, children, is that fine? So to express to express the HCF as a linear combination of the given numbers, you should first find the HCF. They have not asked you to find the HCF anywhere. But when they say express the HCF, that means you should first find the HCF. So that's why we found the HCF first. First, we found the HCF 23. Then you should express it as a linear combination of the two given numbers. All right. Okay, I think you need to practice. So we'll try this one and then I'll give you the test. It's 8:30. I'll just give you one question. It is not a test. Children will practice and then we'll take a test.
Ma'am, I found the HCF.
Yeah, what's the HCF?
6, ma'am.
6. Okay. Yeah, I think you can proceed to express it as a linear combination of 30 and 72. Yeah, Tanishka, 6 is equal to 30 minus 12 into 2. Very good. Next, write that as it is 6 is equal to 30 minus. So in between 12 and 2, which is the remainder? Between 12 and 2, which is the remainder? 12 is the remainder. So write 2 outside as it is. Write 2 outside as it is. Now write 12 using the division algorithm. Yeah, what is it? No, tell me, I'll write. 70 minus 30 into 2. Very good. Okay. After writing this, see, you should use the brackets and all that carefully. See how I've written it. Now, write 60 as it is. Look at the board. 30 minus. Now we'll have to multiply 72 and 2. So don't write 72 into 2 and write the product 144. 72 is the given number. So write 72 into 2 as it is. You're multiplying 72 and 2. Write it as it is. Now minus into minus plus. Now you have to multiply this one and 2. Now will you multiply 30 with this 2 or 2 with this 2? 2, because if you multiply with 30, you're disturbing 30. 30 is the other number. So don't disturb 30. So 2 you should multiply. So what should I write here? Just for yes, you louder. 30 into 4. Okay, 30 into 4. Next, what is 30? 30 means 30 into 1, correct? 30 means 30 into 1. So there is 30 into 1. That means there's 130 and then 4 30s. So totally how many 30s? 5 30s. So it will be 30 into 5. Correct? Minus 72 into 2. Correct? Don't multiply. 30 should be seen as 30. 72 should be seen as 72. Now, the formality is the connector should be a plus sign. Okay, so 6 is equal to 30 into 5. Change that to plus 72 into minus 2. Minus 2. So now we have written 6 as 30. You can write x also. 30x, you can use a and b, m and n, anything, p and q, plus 72b, where, oh no, y, x and y. Okay. Right? Y, where x is equal to 5 and y is equal to minus 2. All right? Okay. Okay, since we have to see the, sometimes children, I might make an extra online class on Sundays. The time will be really odd, but you have to adjust like 9 to 10 to discuss the answers, because I can't spend time in the class to discuss the answers. Okay, so sometimes, you know, now the statistics itself, actually, it's better we discuss, see the answers in a separate class. And people who don't attend can use the, recording. Because that's better than, like spending, see, I give you assignment, then you work and we again spend time in the class to see the answers. All that is highly time consuming. So maybe we'll connect on Sundays for half an hour. Quickly, I'll show the answers. So you can take a screenshot or whatever. You can have your answers with you. I'll show the answers one by one. I'll show the answers because it will be ready. So I'll show the answers so you can check yours. And then if you have a doubt, you can ask immediately. Otherwise, you can make out from my working and your working, you can make out what mistake you've done. You can ask me if you have a doubt, or if you feel, okay, I can help myself, just take a screenshot and we can see the answers quickly. So it's done. Now we have to spend some half an hour or something now in the class to do that. Shall we do that? Do you want to see the answers now? We'll see it on Sunday. Now you're forced to say yes for Sunday. Okay. Done this, children? This is over? Online students? Madhumita,
Yes,
Pratik,
ma'am.
Rakshita, and Arjun.
Yes,
Finish
ma'am.
writing? Yeah. Okay, so this is FA3. Take out long rule sheets quickly. Ready? Write your name, date, FA3. Spread and sit, girls. The two friends spread. Yeah, do this. Yeah, that's all, children. Only these 4 questions for today. Less than 15 minutes, you should finish. 10 to 15 minutes, I'll wait.
Completed, ma'am.
Yeah. All the four sums, Madhumita?
Yes, ma'am.
Okay. Immediately take a picture and put it on WhatsApp for me. For the fourth one, I want some working. I don't want you to guess and write the final answer. Whatever there should be some, the method by which you approached that answer. Simply don't write the final answer. Yeah, so in 5 minutes, online students, I should have received your photos on WhatsApp. In less than 5 minutes, online students, I should have received the pictures on WhatsApp. Offline students, please stop working before 5 minutes. So you have less than 5 minutes time. No stress, no tension. Do how much ever possible. Whatever you work correctly. That's all. Anyways, we are going to learn. Yes, others, Arjun, Rajit and Rakshita, hurry up.
Just a minute.
Date, name, FA3. Real numbers. Yes, Rajit, Rakshita and Arjun.
Just 2 minutes, ma'am. Taking photo.
Okay.
I sent it.
Yeah. Yeah, I've received from Pradit, Madhamita, and Arjun. Okay, very good. Online students. Yes, offline students, please stop working. I've received the copies from the online students. Please stop working. Date, name, real numbers, FA3. Yes. Ritika, please come. Raghavi. நாலு நம்பர்ஸ் இருக்கு நீங்க மூணு நம்பர்ஸ் தான் எழுதிருக்கீங்க 92 690 7161 and 7378. You didn't notice 7378? Please sit down, sir. Yeah. Yeah. Actually, date, name, FA3, real numbers. So what is missing? Date, name, FA3, real numbers. What is missing? Yeah. Okay. All right, children. So let's see the answers for the first one. Can you recall what you got for the first one? Yeah, for the first one, it's 2 here, correct? Then 7, 11, 13, correct. If you've got these numbers, you're right. 2, 7, 11, and 13. Online students?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so 2, 7, 11, and 13. Second one, what's the HCF? Of 92, 690, 7161, and 7378. Couldn't find. Oh, you missed one number. Tanishka? Krishmi? Danya? 1. Online students?
Ma'am, is it?
HCF of the 4 numbers?
Is
Ma'am,
it
I got 2.
1, 2, 4, 6?
One by one. Madhumita?
Even I got 2, ma'am.
2, huh?
29946.
Ma'am, I got
One by one. One by one. 1 minute. What is the answer you got for the second one? Arjun.
131.
31, is it? Okay. Madhumita?
2, ma'am.
2. Prajit?
29946.
Okay. Rakshita?
2, ma'am.
2. Class? 31. 31 is the right answer and Arjun has got the right answer. 31. 31 is the right answer for the second one. Very good.
How?
3. No, this by working.
Okay, show the workings, please.
Yeah, sure. No, I don't have it at the moment. At the moment, I have only the final answer. I'll share the working with you.
Yes, ma'am.
Yeah. The answer for the second one is 31. 31. 31 itself is a prime number. Okay. The third one, LCM of two numbers is given. Which of the following cannot be their HCF?
500, ma'am.
500, ma'am.
500.
500. What's the reason? What is the relation between the HCF and LCM of two numbers? They are? Okay, let's
Ma'am, I
take
just proved 500 is not a factor of 1200, so it cannot be the HCF.
exactly 500. Among the four numbers, the three numbers 600, 400 and 200 are all factors of 1200. 1200 is divisible by 600. 1200 is divisible by 400. 1200 is divisible by 200. But 1200 is not divisible by 500. So if 1200 is the LCM of some two numbers, their HCF cannot be 500. We can't find their HCF. But of these four numbers, 500 cannot be their HCF. If the LCM of some two numbers, we don't know the two numbers. If the LCM of two numbers is 1200, then their HCF cannot be 500 because the HCF is always a factor of the LCM. So 600, 400 and 200 are all factors of 1200. So they can be the HCF, but 500 cannot be the HCF for two numbers whose LCM is 1200. So see here. Now, supposing you take this example of 4, 8 and 10. What's the LCM? 40. LCM is 40. LCM of 4, 8 and 10 is 40. What's the HCF? 2, not 4, 2. Now see here. The LCM is a multiple of the HCF. HCF is a factor of the LCM. They're related. LCM and HCF, they're related. LCM is big, so it's a multiple of the HCF. HCF is small, so it's a factor of the LCM. See the numbers. It'll always be, this will always, this relation is always found. LCM is a multiple. LCM is a multiple of the HCF. HCF is a factor of the LCM. So supposing two numbers have 40 as their LCM. 3 cannot be their HCF. 7 cannot be their HCF. 12 cannot be their HCF. 15 cannot be their HCF. Because 15 is not a factor of 40 or 40 is not a multiple of 15. So 500. So the third one, 500 cannot be their HCF. And the last one, find the least number that is divisible. I don't know if I have that slide, but I wrote no, divided and divides. So divisible. 1 minute. First question. Find the least number that is divisible by all the numbers from 1 to 10. So that number should be divisible by 1. That number should be divisible by 2. So it's a numerator. That number which you're looking for, should be divisible by 1. That number should be divisible by 2. That number should be divisible by 3. So you're looking for the numerator or denominator. Denominator is 1 to 10. Denominator is 1 to 10. find the least number that is divisible by the numbers from 1 to 10. So that number should be divisible by 1. That number should be divisible by 2. Divisible by 3, by 4, by 5, by 6, 7, 8, 9, and 10. So the denominator is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You are looking for the numerator, which is the LCM, which is the LCM of the numbers from 1 to 10. So 1 is equal to 1, 2 is equal to 2, 3 is equal to 3, 4 is equal to 2 square, 5 is equal to 5, 6 is equal to 2 into 3, 7, 7, 8, 2 cubed, 9, 3 square, 10, 2 into 5. Now what is LCM? All prime factors. Now, so write all the prime factors, highest power. That product is the answer.
2520, ma'am.
Yeah, 2520, correct.
Ma'am, I too got 243.
Very good. That's the right answer. 2520. You understood what? Now I'm sure all of you have understood. So you're looking for the numerator. Is that understood? You're looking for the numerator. Numerator means LCM. LCM. How do you find the LCM? One not prime factors. One is not a prime number. It's not a composite number. It's a unique number. One is 1. 2, 2, 3, 3, 4, 2 square, 5, 5, 6, 2 into 3, 7, 7, 8, 2 cube, 9, 3 square, 10, 2 into 5. Write all this. Then write all the prime factors once. Write all the primes once and raise them to the highest power. That's how we find the LCM. That product is 2520. And that is the least number. That's the smallest number, which is divisible by all these numbers. Why that's the smallest number? Because all the multiples of 2520 also will be divisible by 1 to 10. Because that's the smallest number, because all the numbers, all multiples of 2520 will also be divisible, right? So 2520 is the smallest number. 2520 is the smallest number. There are many more numbers, infinitely many numbers divisible by the numbers from 1 to 10. All the multiples of 2520. So the smallest is 2520, which is the LCM. Okay, so that's about the answers, children. So complete this as homework by the next class. Just take down this in your book. Online children, please write down the questions. Yeah, that's it, children. Madhumita is not here, joined. Danya. Tanishka. Pass it to Tanishka. All right, online students. So that's it for today's session. Thank you. Good night. You may leave the call.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Ma'am.
Thank you. Good night.